All right, I think we can start now. I've already finished setting up my Sea Lion and everything, which is the IDE I'll be using. Anywho, let's go. I hope I'm audible. We'll come to know as we go, I guess. All right, so stop recording. That was a shortcut that I should not have hit. This is the Vulkan specification. One of the things you need to keep handy if you're going to be using Vulkan for your projects and everything. Now, there's a lot of ways you can configure a project. I'm using C++ here. So that means we've got variety in terms of the build systems we can use. On Windows with Visual Studio, people prefer using the MS Build, the built-in system. But I like my settings in a more exposed and easy to access way compared to the XML files that MS Build creates. So I generally prefer something like sconstruct, scons, or CMake. So I'm going to use CMake, and since I'm going to use CMake, I'll use CLion, which is the go-to JetBrains CMake IDE. My only problem with OBS here is not being able to see chat in like while OBS is minimized. So maybe I'll look at it, maybe I won't sometimes, I guess. Either way, I will start. I don't intend to like keep jabbering. I'll only jabber when required, but more or less I will keep jabbering, let's put it like that. I'll make a new project. We're starting from scratch. I could do it completely in text by making like the CMake project entirely from scratch and then importing it into CLAN. But why do it in a painful sort of way? So yeah, coming to CLAN, I will obviously use C++ with CMake. Whatever, let's go for the default location. Aster. No, I've decided Inferno. And Aster was an old project. I'm gonna call this Inferno. Let's use new standards, right? C++ 17 is like a nice default layer to start with, but C++20 provides some features that I really like I forgot what they call it, but it's initializers with names. So C++ designated, I think, designated initializers. Yep, designated initializers. So they're quite clean. You say in the brackets, you can do dot with the name of the field to assign to them. This is going to come in very handy with Vulkan. C++20 only feature, so it makes sense to actually do this. Also, I like keeping everything in, small letters. It's just better that way. Inferno, create. So there we go. No need for AI. We are very good at this. MinGW. Yeah, I guess that's all right. Tool set wise. Uh, or we could use Visual Studio's internal systems. We've got Ninja and bundled LLDB, CL. Okay. Everything's fine with this one. MinGW is default. Again, GCC, Ninja, GDB, all good. I prefer LLDB, I guess. Now, architecture, MD64, let's leave it default, right? Let's leave everything default here. This is one of the reasons why I actually prefer doing things manually. I do not know how to use these configurators. So we'll just go ahead with the Visual Studio one and see how things go. So this is our cmake list.txt, cmake build debug thingy. Yeah, I just don't like this. So there's a way to make profiles, cmake profiles, and that's the one I would prefer to use. If anybody's watching, let me know, yes? CLAN documentation, settings, and all of that. Inferno, edit, Inferno target executable, working directories, yada yada yada. Yeah, that looks all right. Debug, CMake profiles. Okay, yeah, debug. We're using MinGW. Fine. Default here. This thing is blah blah blah. Hmm, not entirely comfortable with this. We'll come to this in a second. It's already set up the CXX standards and added an executable for Inferno with a main.cpp. First things first, I prefer converting this into a directory uh, just to put my source files into it. So directory .c, move the main in there, Inferno src refactor, so that we have build directory separate from our source directory. CMake's automatically taken care of it. If you run it, it's just going to run hello world. It's probably already written that, yes. Nothing's configured in my CLion yet. So let's add a VC package. There's a lot of ways to actually handle this. You can add it as a subdirectory, which is very cross-platform. Whether you're using CLion or not using CLion, it just tends to work. Get started. So what is VC package? First of all, it's the package manager, right? It's a way to actually just find, fetch binaries or source files that you can integrate libraries instead of doing the old-fashioned way, which is adding a third-party directory and then, trying to figure out how to handle that. So blah blah blah, using install and use, yeah, directly with CMake. In a simple way of doing things. So one of the ways you can do it is to just integrate it, just add it as a submodule in our project here. But if I remember correctly, the best way to do it in CLion is to actually um, add it as a definition add it as a plugin to CLion itself. So the best way would be CLion. Actually, I would use submodules. That way we don't need to rely on CLion. So if I later decide I'm just going to use Emacs with nothing else, we could just go in that way. So let's open this in the terminal. Yes, we've got everything here as it was. VC package is gonna end up as our vendor directory. So git clone, nothing special there, just git clone into VC package. Eeps, Control C. Not the best idea. The reason is quite simple. You should add it as submodule. Delete. Yeah. Git submodule add, and we'll just start the git part of it. Git repository. Oh, it's not a git repository. Ha. Okay, initialize the git repository in Inferno now. Git st. Okay, things seem to be working. Now we can actually do the git submodule add VC package. It's cloning. So let's look at how to use a VC package with CMake. So next is to do bootstrap. We'll let it run first. Oops. Yep. So cd VC package. This is the VC package essentially. Now we just need to run the bootstrap.bat file. Are we sure there's no ps1 file? Yeah, there's no PowerShell. So bootstrap cpkg.bat, that will download and essentially install VC package with itself. I do not want metrics, so we will remove that by rerunning the script with disable metrics. Okay, much better without being spied on, says the guy using Windows. Okay, let's. So now that VC package is bootstrapped, let's just look at how to set up the paths. So configuring requires us to add environment variables for VC package root. Um, yeah, not entirely necessary, I think. I don't generally do. I don't generally need to add the VC package. If it's submodule, you don't need to check the environment variables because you're going to be using a direct path to VC package. So VC package dot exe new application. So that will create us the VC package.json, which is a manifest file that declaratively tells you what things we'll need. One of the things it adds is the FMT library, FMT lib. It's a way to format everything in a more convenient way. If you're used to Rust, it's similar to the way Rust prints things. Oh, yeah, of course. VC package, add. It's gonna be fun. FMT. Cool. So now that it's there, you can see ports.json is just this FMT file here. Not a big deal. But another thing we'll have to do is set up this profile configuration that requires us to add the toolchain file. So we copy, you know, actually we just need to copy this part, scripts, yada, 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 for the toolchain. For the debug, edit CMake profiles. So this is our CMake profile. The options are all CMake options. No, that's not what I wanted. So yeah, okay. This one should be build. Prefer to keep it simple. There we go. Advanced. Now what's the name of that thing? CMake toolchain file. Yeah, I'm not going to use this. Okay. It might be a thing, but I will not be using it. New file cmake presets.json. It's simply just better to do this way. Yes, add it to git. That's cmake json. Copy, paste. Once you've pasted it, change this into debug. Binary directory is still build. We don't really change much there. We could actually put it like build debug, but doesn't really matter. We could do that still, but anyway, build toolchain file is VC package root, but for us it's just here in VC package. So yeah, it just goes inside VC package, cancel. So scripts, you see, and it will find its way. So build systems, VC package or CMake. So this will automatically find the VC package CMake file, which will add the locations and all the variables it requires for us to be able to find the thing directly. So now for the profiles, reload with all configuration files. We should actually do this. Okay, that still didn't change much. Debug, edit CMake profiles, debug plus release. Okay. Yeah. Keeps adding more, but doesn't allow me to find the built-in presets from this place. So reload, view. Yep, there we go. So the debug preset here. So we'll delete the original and this will enable this profile. Now that allows us to essentially define everything we want within the file instead of having to go through CMake, go through the IDE. I prefer it this way because it makes things nicer. I mean, I've already seen you here, but hi again in case you're still hanging around. Okay, yeah. So we have git modules. We should add a git ignore, new file dot git ignore. Yes, added to git. Now in git ignore, we will ignore idea because client will use .idea as a folder for everything. We will also ignore. Uh, I don't think I need to ignore VC package. It should be able to ignore it by itself. But I will ignore build because that's our build folder. Now, given this, let's try to build the project. We'll go to the CMake here. Building x86, yada yada yada. Keeps compiling. Everything has compiled. Run. Hello world. All right. Now that is based on just basic C++ IO stream. We are going to use core.h. Now you can see FMT is actually shown as not existing, which is fair. FMT is not a part of our system just yet. But yes, hello world and semicolon. So this is how it should work. FMT is not a part of our includes yet. So we can just add that by first finding. So find package FMT required. It's actually written here. So they have the examples written here. See, FMT config required. Okay, it's not FMT. And it's from the config. Then for the linker, we will link everything. So target link direct link libraries to the target Inferno. So that's our main target. We will link it privately, which means it does not get further linked to the dependencies, to anything that might depend on Inferno. We can choose to change this if required, of course, and FMT. So that should compile. Okay. Inferno still does not compile. Undefined references to basic format string view because of min.gw. Okay, let's see exactly what the problem is. Did we at least get this correctly? Yes, seems to have. Might be a good idea to see what configuration this tends to use. I do prefer using Linux because it's easier for me to find the compiler and stuff. It's trying to use the min.gw, but undefined refers to basic string format from FMT. So this is still FMT lib. It's trying to link itself to FMT. Target link libraries, yes. Should work. Checked Inferno. Doesn't make much of sense here for it to not be working. It seems to be okay on this side. Building still does not work. Undefined reference to how do we fix this? Well, we could check for compilers ourselves. So which does not exist on this? Because again, we are on Windows. So which does not exist? Do I have to use the built-in profiles? Default manage toolchains, bundled min.gw. Where is the min.gw? Visual Studio cl.exe. So this one's the toolchain file, right? So instead of a preset, it's the toolchains. So it's better for me to use Visual Studio, it seems. So that's my default now. CMake, delete. Okay. Let's see again if this works. It still seems to be using use default toolchain. Okay. The thing that always works. There we go. The funniest thing you can do any day. Just delete the thing and restart. Perhaps it was using MinGW instead of using. Yeah, there we go. So because we deleted the files, we deleted and restarted the toolchain thing from scratch. So now it seems to work with FMT. This is how I prefer doing it. Use the MSVC compiler on Windows, use Clang on Linux or GCC, but MinGW always tends to give me troubles. All right, so now we've got the basic CMake and VC package setup done. It's the wrong Vulkan spec, whatever. We'll come back to it later. Now, we're doing Vulkan, correct? So let's see what the starting point of a Vulkan application is. The way it works is you've got the basic Vulkan header, which is defined under the Vulkan spec essentially. So you can keep reading through the whole thing. It's generally massive. This one is, yeah, you see, title page introduction. You don't have to read through the whole thing. We never really do. All we need to do is start off somewhere, and that somewhere is to just create a Vulkan instance. What is an instance? It is the initialization of the Vulkan's internal like drivers and stuff. So yeah, how do we start with this? First things first, we need a way to link Vulkan in. So that we can do with find package again. So find package, Vulkan, I think V is capital, yeah. Config required. I don't think we're doing config here. Target link libraries, Inferno, private, Vulkan. So with Vulkan, I want to link with Vulkan headers. I think it's called Vulkan headers. Let's see if it works. Nope, Vulkan headers not found. So I know that for CMake, the package for Vulkan is called find Vulkan. So in find Vulkan, I should be able to Vulkan headers. Oh, it's just called headers. Let's see if we can find that. Yeah, great. So it's able to find headers. Now with that, I need other things. So the way Vulkan works is I've installed the Vulkan SDK. You can see it at LunarG Vulkan SDK. So LunarG made the original Vulkan SDK and then they open sourced it. Vulkan, the API or the specification was initially crafted by the Kronos group. That's like AMD and everything coming together to find, a way to make APIs. Funny thing, Apple was a part of Kronos, like the committee that actually did the Vulkan thing, and then they just decided to not support Vulkan on their systems. Instead, going for Metal, which means now for the Vulkan SDK, you still have Apple, but for Apple, you use what is known as Molten VK. So the way that works is all the Vulkan commands get translated into Metal commands underneath the API. But anyway, the way you do is you get this SDK. So I've already installed it beforehand, and you link the headers, or you could link the entire library, preferably just the headers, because that way you can load whatever's the available library on the host system. So when I give you a binary file, instead of using the Vulkan that I've shipped with my binary, which may not be compatible with your GPU drivers, maybe because it's too modern or too old, I just link to whatever Vulkan headers you have, Vulkan library you have. But in order to do this, when I give you headers, this these headers only define function pointers. And these function pointers must be loaded manually by us as we go along. So for these things, these basic parts, I prefer using Vulkan tutorial. It's a decent site. Vulkantutorial.com teaches you enough about it to be able to, handle doing Vulkan stuff. But in general, I do not entirely follow everything here because they use a lot of exception handling and stuff. Some people don't like exception handling, especially in game dev, myself included. So, yeah, I won't be using exactly what they're doing. But okay, first things first, we will need a Vulkan uh, header. So you can see GLFW actually can include Vulkan if you ask it to do that. GLFW include Vulkan. And if you ask it to include Vulkan, it will be able to actually just load all of those pointers I was talking about internally, right? GLFW can do this. SDL, which is another library people tend to use for video game window handling. So GLFW is a window handler cross platform. SDL does similar things. SDL can do a lot more. It's built to be able to, handle some small amount of direct buffer handling. Like you can make 2D games in SDL with nothing else. But other than that, it can also do window management in a very nice way. So most of the Valve games and a lot of modern games actually use SDL as their window backend. Some use GLFW. It really depends. SDL's pure C and has existed for a long time, so tends to be like the way to go. But we will not be using the built-in system with GLFW. The reason for that is because I prefer using this thing called Volk. Okay, yes, should call it Vulkan. Yeah, so Volk is a meta loader. You can read what it does. Essentially, it will allow you to load Vulkan from the host computer, and it works pretty much everywhere. All you need to do is add the volt.c and volt.h headers, h files. But nowadays, Vulkan actually comes with Volk built into it. So see, uh, CMake actually can point me out that Volk already exists as a part of the system here. Hmm, Volk, but the target was not found. That is weird. Should work normally. Vulkan.volk. Find Vulkan, Volk, defined if SDK has. Oh, defined if SDK has the Vulkan meta loader. It's a flag, it seems. Hmm. Does seem to be targets. If SDK has Vulkan meta loader Volk, it should be able to link. Hmm. Okay. Okay. Let's see if we can actually just include Volk here. No. Vulkan.h. I cannot do Volk here directly, but I do have Volk installed. Um, hmm, interesting. Vulkan found, Volk found. Make if. I need to be able to check the if. If found message found and if it's not the best looking way to go around with things. We will not link with Wolf here because it seems to just not compile if you do that. Doesn't say anything about Volk being there. Open include empty. Did I leave something there? I did in fact leave something there. Okay. Build worked. Hmm. Somehow Windows is very hard to use compared to Linux. Not that it wasn't expected, but I'm certain that I already have Vulkan installed. Layer management, tools, Vulkan info, for layers. It's a lot of questionable material there. Anything in the chat? Nothing. Okay. A lot of questionable material here, but like none of it is currently useful to us. Let's just look into the SDK directory. So that's in home C Vulkan SDK 2.83. Yep, Vulk's right here. Vulk should be available to me. So with vcpkg, Vulk and Vulk headers, find package Vulk. Okay, perhaps I should actually find Vulk instead. So find package Vulk, Vulk. Doesn't seem to be working either. Let's see if that works better. No. No, this will never work like this. Let's see if this works. Called with invalid arguments. Why doesn't this work? Find Vulkan C make Vulk not working. Version 3.25, we had at 3.28. So it shouldn't be a problem, but let's put it to 3.25 anyway. Let's move include directory. It doesn't seem to be working for us anyway. Vulkan Vulk library. Let's see that. If Vulkan, Volk, found, search, Volk at Vulkan, Volk library, and if. Yep, some reason I can't find Volk at all, which is extremely weird because normally Volk should be available as a part of the SDK, which it is. As we saw here, Volk is right there. Somehow, however, CMake is not able to find it properly. Dude, Volk, it's right there. Yeah, let's see how to. Seems like the wrong Volk. It's Volk, Vulkan, SDK. Back to 5. Not to the same thing. Imported targets. Result variables. Vulkan is the main library. Vulkan headers. We provide the headers. We use Vulkan headers with Volk to make things work. Okay, actually, I'm just going to skip this whole thing. Just gonna go for Vulkan, and we can do the headers part later. That way we can move on instead of trying to figure this out right now. So we do Vulkan. There we go. First things first. So in order to get Vulkan up and running in an actual application, we need to create what is known as an instance. Instances are essentially just these ways Vulkan actually talks to your drivers. So that sort of pointers to the driver itself. But in order to get an instance properly, generally you should Vulkan create instance. That's the function you will use. You can see that it has some allocator callbacks, an instance that it needs. That's the output actually, and a create info. So instead of taking parameters as a okay, instance create info. So instead of taking parameters as function parameters directly, it instead takes a struct. So instance create info equals, and we can do this. Here we could ask for designated initialization. So this will create the entire struct. We're gonna just do this manually one by one after we just format this whole thing. So code, format code. Okay, now there's a lot of fields here. So S type, generally in C, because Vulkan is a C API, we don't have a concept of the type of a particular struct once it's a pointer. So you are able to sort of mix pointers as you like, even though generally they'll stay correct. they can move around as in how it might want to go. So in Vulkan especially, you have a lot of casting that happens between different types of these structs. So I can actually give you a second different struct instead of giving you instance create info. Since there is no inheritance in C, we need a way to be able to discriminate these different types. So we've got an enum field called S type. So in this case, the names are simple. I don't even need to look for documentation. This is VK structure because it is a structure of type instance create info. See, VK structure type instance create info. That's it. That's the field. P next. P next should be null. There's nothing in it. Flags zero. We don't really need the flags. And what you actually can do is you can just skip these in designated initialization. We still need an application info, so we have to create that. VK application info. So okay, there's a question now. Do we use this or do we use this? So what I'm going to do is I'm actually going to follow the Vulkan way of doing things, which is the application info. So personally, I'm a bit biased towards the other one. Anyway, not much of an option I have if I want to be uniform with Vulkan. Application info, again, designated initialization. S type would be VK structure application info. There we go. P next is nothing, we don't need it. Application name, Aster demo, because the engine name will be Aster. Application version, this is a uint32. This actually is a macro version. No, so we can make version. Yeah, make version. Major would be 0, minor would be 1, patch would be 0. So it's 1.0.1, right? Engine name is Aster. No, it's not Aster. We're making Inferno. G. Inferno. I'm too habituated to making Aster. Okay, Inferno. Engine version. Again, VK make version 0.1.0. API version. So here we can just say VK API version 1.3. The thing is, however, in reality, we're not sure if my current drivers would have Vulkan 1.3 or not. So API version 1.3 means it's looking for Vulkan 1.3, which we're not sure about. So we need to be able to actually look if we have a version 1.3 or not. And, we should do that testing. So generally it's like to do, I'll just add my to do here. Check if VKPI 1.3 is support. If it's not supported, we should like do something else. Either find another way of solving this problem or just go for something else altogether. Like maybe use OpenGL or something, saying Vulkan 1.3 is not supported. But generally you'll fall back to like 1.2 version of your renderer if you have one, something like this. Okay, enable layer count. Now, generally, I would use validation layers, which is a way that Vulkan inserts sort of calls between your normal calls. So you make a function call. Instead of going to the Vulkan DLL, it will go to your validation layer. Validation layer will take that as information that it might use to debug things and then pass along that information, like pass along the original call directly to the Vulkan drivers. So that way it can do analysis based on what calls you're making. And validation really helps you ensure that you don't have much bugs, which tends to be a problem with these kind of things, right? Like when you're trying to do make a call that shouldn't occur before another call, perhaps validation layers will actually tell you that, hey, you should have actually tested that. So yeah, I think it's const car star validation layers. We need an array equals the validation we need is vk validation layer. Oh yeah, it doesn't have those things. So we can actually look for it again in the Vulkan configurator. So layers controlled by Vulkan configurator. Layers. Chronos validation. So this is the Chronos validation layer. That's the one we want. VK layer Chronos validation. And we will actually use it as string. So be careful with it. VK layer Chronos validation small. Okay. So that is our validation layer. We will pass that to the enabled layer count as 1 and enabled layers as validation layers. So there's a C++ API to Vulkan. It makes it easier. You can actually pass an array directly. So you just say enable layer names equals an array of this thing. You can just pass this, not this, but like a vector, for example, std vector, and it will just work. You don't need to provide the count separately. The flip side of that thing is it uses exceptions, or you can avoid using exceptions, but then it's a bit weird to use. We could use that. We could use that. One of the things it also does is removes your need for doing VK structure type application info. So let's do it actually. VK HPP, VK application info becomes VK application info. You see, you don't need that. It automatically gives you details about the structure. No problems on this particular front normally. Validation layers is still fine. VK instance create info. Again, S type is automatically created. Application info. Generally as it is. Validation layers, I wouldn't need to write the length. I mean, I should write the length actually. Yeah, so let's make this a vector, or let's just initialize it inside this place. So this is the cool part of using Vulkan. I think the name is also different. So let's redo this. Let's keep this part and remove this. Designated initialization, we don't need S type. Okay, no struct constructors. So we need to define something here. For vk hpp no struct constructors. Otherwise, they have constructors. Limited initialization. S type is nothing. Application info. Oh well. How long has this lasted? 48 minutes. Not not too far that we've gotten, unfortunately. Anyway, let's just look at something for a second. Any comments or something that I haven't seen? No, none whatsoever. I think I'm gonna end this here.